Hi everyone. Today we're going to do a review of how to find the centroid and the orthocenter of a triangle using graphing. So let's start by looking at the centroid of a triangle. Now please remember, a centroid is the point of concurrency of the medians of a triangle, meaning that it connects the midpoint of a segment to the opposite vertex. So we've been given this graphed triangle here. And what we're going to do is find the midpoint of a segment. And remember, to do that, we average the x's and we average the y's. So we're going to find the midpoint, and it doesn't matter which side. I'm going to use QR. So I'll find the midpoint. So I averaged the x's and y's, and I got the point 3,6. So I just put it on my graph. Now all I need to do is connect that midpoint to the opposite vertex. That means I just take a ruler and I connect this point over to this corner over here, the opposite vertex. And that will get me the first median that I need. Okay, so I got this green line right here. Now the next median, I'm just going to do the same process again. I find the midpoint of PR, again by averaging, and then I'm going to put it here and then connect it to this opposite point. The midpoint of PR was the point 4.52. So I put that on this line over here. And then I used a ruler to connect it to the opposite vertex. Now all I need to do is find the place where these points cross, and that is my centroid. Okay, this point is the point 3, 4. So my centroid is the point 3, 4. So that's how you find the centroid. Now let's see how to find the orthocenter of a triangle. Please recall the orthocenter is the point of concurrency of the altitudes. And an altitude is the line that begins at a vertex and is going to be perpendicular to the opposite side. Now notice it says the line containing the opposite side, because altitudes are allowed to go outside the triangle. Now we have an acute triangle, so it's not going to go outside this one, but that wording is very specific, and it's that way for a reason. Okay, so let's find our altitude. Now perpendicular implies that we need slope. That's how we find perpendicular lines when things are graphed. So I'm going to find the slope of this segment here, JK, and it goes up 1, 2, 3, 4, and over 2. So it rises 4 and runs 2. So that slope is 4 over 2, or 2. But we need the perpendicular slope. So let's see the work on how to get that. Notice what we do is to get the perpendicular slope, you flip the slope fraction. This was 2 over 1, so I got 1 over 2. And you change the sign. This is now negative. So it's negative 1/2. So it's going to begin at the opposite vertex. I did the slope of this line. So I'm starting over at L. And I'm going to use the slope to get more points. So I'm going to go down 1 and over 2. But notice it's getting further away from my triangle. So I can also go up 1 and back 2 and create a line. So that gets me this red line right here. So I just used the slope to get these points, and then I just connected them with a ruler. Now we need another line, and they gave us a triangle that has a horizontal line, so that makes life a lot easier. If they didn't do that, you would just do these steps again. You'd find the slope of another side, and then use the slope from the opposite angle. But they gave us a horizontal line, so perpendicular line to that would be vertical. And remember, it has to start at the opposite angle. So I'm going to start at K and draw a line straight down toward JL. And that gets me this green line right here. Now all I need is the point where they cross. They cross at -2, +4. And that is my orthocenter. So all I need to do is write down my answer, -2, 4, and I'm done finding the orthocenter. So please let me know if you have any questions about this. I hope it was helpful, and I'll see you soon.